Okay, good evening, everyone. So today we OSGeo Nepal and Nepal Geomatics Engineering Society (NGES) together hosting a Geo series technical session episode 13 on handling large spatial data using PostgreSQL and DuckDB. So today we have our very own speaker, engineer Kshitiz Raj Sharma, who is open source geospatial developer, project owner, map data access service at HOTOSM. So he is going to give us some knowledge, some information about how to handle the large spatial data set using PostgreSQL and the DuckDB. So yeah, we are going to
Recording
start
is
this.
on.
We are going to start this session. So Kshitij, now the floor is yours. You can start with the session. Yeah.
Okay. Thanks, Rick. I hope I'm audible to everyone. Okay, perfect. Thank you, Tech, for this. And I've been really fortunate enough to start our technical session with sharing my experience and a couple of knowledge that I gathered over the years. And then in this specific session, so my main goal is to convey information about like if, let's say, the data that you are dealing with starts to grow in not in megabytes, but it starts to grow in gigabytes, right? So when you need to deal with gigabytes of data, and then like real pain starts to happen, like you might notice strange bugs in your system, or like even like um, some kind of uncomfortable situation you might find yourself in. So yeah, I'll try to bridge that like little bit gap, how we can handle large spatial data. I will mainly talk about two um, tools like database system here. One is PostgreSQL and another is DuckDB. I will kind of like also demonstrate, like I have gathered some resources for this, specifically for this session. So I will also demonstrate and walk through the resources and maybe like walk you through the real data instead of only mentioning it theoretically. So let's begin. Um, so contents, those are the contents that I have prepared slide for. I only have 10 slides for this session, and mainly I will be focusing on inputs like, okay, what are the real life case scenarios, how you can do it, what are the specific problems that you might tackle with. So I will first introduce you with PostgreSQL, very quick, DuckDB, again, very quick. And after that, I will talk about, okay, what are the points that you need to consider when you are about to handle large spatial data. When I say large spatial data, I will also quickly touch up what type of large spatial data that you might want encounter with. And then second, I will also talk about experiments, like experiments that I have been doing since past couple of years, what I have learned so far, and what you can learn from this, so that like you won't go through the same problem that I have gone through. And then I will share my experience. After that, I will also share what is the use case of the DuckDB, what is the use case that I am applying DuckDB for. And then I'll share a little bit of personal perception about DuckDB, since that also has been in hype since like a couple of months, especially in geospatial domain. And I will finally walk you through the resources that I have prepared for you. Let's begin. Feel free to drop your questions in the chat, as Tech mentioned. I can see your chat, but I won't stop. But feel free to just keep them coming, and then we'll go through it at the end of the session. PostgreSQL. Most of you, I think like most of you are familiar with PostgreSQL. If you are not, it's a most popular open source database. I feel no hesitant. I'm not hesitant to say this, like it's the most popular open source database. Like I've been really proud that I've been a user of Postgres since I begin my journey in geospatial domain. and it's been great. Like it's never disappointed me at all. So it's reliable because PostgreSQL has been in development since 90s. It's feature rich. You'll find every features that you can possibly find with modern geospatial databases. And I'll be really surprised if there are none in PostgreSQL. So Postgres really tries to cover all of the aspect, not only in geospatial. But in most of the cases, you will hear me talking about the geospatial perspective of the database here. Next is powerful indexes. So what are indexes? Indexes is like, let's say databases, they consider databases is like just bunch of rows, very huge bunch of rows put into the together in an organized way so that you can use it to query the database. Let's say you have thousands of students. If you divide thousands of students into 10 different classes based on their experience, based on their knowledge, then you can simply call, okay, student of grade 5. Student of grade 5 who has is greater than 10, greater than 15, so that you can really organize it, and then you can retrieve the information that you are looking for. That's why databases are used, and there are a lot of databases out in the market. PostgreSQL is what we are interested in because Postgres has a really cool special extension called PostGIS. I know most of you are familiar with that. It has lots of special functions. It can actually define point, line, and polygon in a database level, not in a, like, let's say, in a column level, right? Instead of specifying latitude and longitude on the table, it can actually specify it as a, hey, this is point contains of lat and long. You can add Z if you want, and it can store it as a point. It can store feature as a line. It can store feature as a polygon. It's a basic. It's not limited to. But this is how PostGIS works. Initially, it started with, and then later on, like PostGIS, like added a lot of functionalities that are especially useful for the geospatial people. It has large dev support group, and the good thing about Postgres is whenever you are trying to build something with Postgres, let's say you are trying to build something with you are trying to build a navigation application, you need to store all the like latitude and longitude, all the places that people have been, or maybe locality, right? And then you opted for Postgres. You do not need to worry about, will it be supported in AWS? Can I get it in Azure? I have some Azure money, or like I have some other service providers. Will it be supported? Like most of the popular service providers, they provide production ready database support. AWS provides RDS. Azure also has database service, especially for Postgres. So you want to run into the problems when deploying the application. That you might have noticed, Heroku also has support for Postgres. So it has large support. And also, as I mentioned, post extension like PG raster, not only vector, Postgres also supports storing the raster files as well. So next, DuckDB. What is DuckDB? DuckDB is pretty new, but like as I said, it's been in hype since couple of months, and the reason for this, there is also a very strong reason why DuckDB is popular nowadays. It is very simple, like architecture wise. DuckDB is just like a mini pocket device, like a mobile. You can just keep it and walk it around, keep it in your pen drive, and then like just pass it to your friend, or install it in your laptop, just like how you copy files, right? It's not that complicated. As I said, like portable. You can run it in your Linux, run it in your Mac OS, Windows, wherever you want. It has support for it. It does say it's feature rich, but I might counter this point that since it's very new and a lot of developers just started to using it, so I'm pretty sure it will be very feature rich on nearby futures. But as of now, it has pretty decent features. Like let's say it can read your CSV, or like you are in a household survey and you have all structured, unstructured data just in CSV. Everybody understands CSV. They just insert it in CSV. Now you need some database so that you can run some analysis on it. DuckDB could be the one for you. Like it can easily simply swamp up CSV, You don't need to install like huge softwares like Postgres, like, you don't need to set up anything. Just install DuckDB, insert your CSV into DuckDB, start shooting your queries. It's as simple as that. DuckDB claims it's really fast, and it is in some cases, but it really depends upon the use cases that I will talk about on next slide, right? And yeah, like, it has a lot of extension. The good thing about this, since this is also a event of OSGeo Nepal, both of them are free and open source, so you can use it with any. You don't have to worry about like, okay, either it's do I need to pay for it, any license compile that I need to follow. So it's a free and open source. As long as you follow the free and open source MIT licensing, you're good to go. And one thing, main thing that we are all interested in is DuckDB supports a spatial. So initially it didn't use to support a spatial operation, just like Postgres. When Postgres initially came out, it was only used for like relational queries. It was excellent relational database, but it didn't had PostGIS support, spatial support until and unless at the point when PostGIS made its entry, and then it changed the future. Same like that, DuckDB also has a spatial support. It is not as rich as PostGIS, but it covers some basic functions like ST intersection, ST within. You can also do like ST geometry from geospatial. You can also do lookup by features. You can join by a special. You can perform a spatial join. So DuckDB also supports this. Good thing about DuckDB, recently, I think a couple of months ago, they also added support of OGR. What does that mean? That means now, let's say you loaded something in DuckDB that is spatial, you are doing your spatial analysis. You can extract it in multiple formats. You can extract it in GeoJSON. You can like simply dump your DuckDB files into save file, geo package, whatever you want. So since it has OGR support, it supports most of the libraries, like most of the geospatial formats when it comes to export. Right. So yeah, it has spatial support. So handling large data, since we know, okay, what is DuckDB, what is Postgres? Now, okay, we know about the databases, but how do we use it? How do we use when data grows? Like if data is just, let's say 100 rows, you are not dealing with much, data incoming and outgoing in just 1,000 entry per month or like 2,000 entry per month. You might not need database at all. Like you can simply store it as a, even you can store it as a JSON or store it as a dictionary, use AWS services, the very microservices. So you may not necessarily need databases. You need database first when you want to organize, when you want to be your system to be scalable, whenever user reach is grown, when people are starting using your application or like using your system. Now you need, okay, my data is really growing. I'm inserting 10,000 rows per day, 20,000 rows per day. How do I efficiently manage that? And there comes like complications, and there comes you need to be really smart about it. First, when you are handling large spatial data, let's say you are dealing with all the buildings in Nepal, right? Let's say you are doing your household survey in all over the Nepal. It's not all over the district. It's not about the municipality. Your ArcGIS or like QGIS or any other GIS softwares will be able to do it for a municipality. Like it has integrated your database. You can do it. But when it excels, like when it extends in a, let's say, country level or a state level, extends country like India also, now you need to be smart about it. First thing to do, you need to understand what type of data you have. Is it structured? Can you make it like column wise? Can you separate? Sometimes it could be just comment. This house has 4 people living in it. 2 people are male, 2 female, and one of them is teaching, but one of them is unemployed. Is it something statement? Is it just a text, right? Can you organize it? Can you make it structured so that you can like maybe frame it a little? So first, understand your data. Second, organize your data in a way that it is structured. from unstructured data in a way that it can be structured so that you can pull it out and like make some good schema out of it. What is schema? I will talk about. So first, make sure you understand your data. What type of data you have? Can you structure it? How much data you have? How much do you anticipate, right? Based on that, you are going to make so many decisions on the next step. So you need to understand your data first. Second, how do you process your raw data? When you say, okay, my data is unstructured, I might need to make some structural changes, I might need to process it. Now you need to understand, okay, how do you process it? How do you collect your data? Are you bringing your IPR with us, or like, are you using mobile or 𝗂𝘀𝗶𝗹 or any service with you, or data is coming from remote mapping, data is coming from imports, or like there is existing cadastre database that you have, right? So you need to understand how you are processing your data, how you gonna get it in your system or get it while you are analyzing the data. You don't need to like get it into the system or build the application itself. But when you are analyzing it, let's say you have all the cadastre data from all over the Nepal, right? And you are trying to maybe do some research how land rights are distributed. Now you need to understand how you process it. Are they in save file? Are they created only with the commercial softwares? Is there any deficiency? So first, you need to make sure how you get the data, processing of the raw data. And another option that I have kept here is choice of database based on the need. When you specify what you need, what type of data you have, how you're going to process it, how you're going to get it. Now you know, is there a growth in your database? Is it a static or size of the data? At least you have approximation. Then you will do the choice. What type of database you need? Do you really need a database? If yes, like as I said, when you clean up, sometimes initially data might seem okay, it's gigabyte of data, but later on after you clean up and just extract the derived useful information from some Python script or R script, then it might be very small. So yeah, that at that point you need to decide what type of database you want. I will say opt for Postgres for everything. Postgres works for everything basically. Like Postgres is like master of everything. And I also remember I was in a Postgres conference before, and one of the Postgres developers said that if you are confused about database, what type of database you're going to use, but you need one, you are pretty sure you need one database, but you are very confused. Do you need to use MongoDB? Do you need to use SQLite? And he said, use Postgres for everything. And Postgres is that extendable. So, like Postgres is very nice. And I won't say use Postgres for everything, but it could be a really nice option. As we have DuckDB, which I will tell how DuckDB jumps into this whole part of geospatial conversation. And then you might not need Postgres. You might get away with DuckDB or any other simple, maybe pandas data frame. You might get away with pandas data frame also. So yeah, choice of the database is needed. How are you gonna make your choice? I will talk about it. Now there is a schema. Okay, so you made your data structured from non-structured data. You made it a structure. I have a ID. I have name. I have land owner name. I have latitude, longitude. How are you gonna structure them? Okay, I'm putting latitude, longitude here. I'm putting cadastre here. Now I have also data from, like, let's say land register office. That is only maybe like I need to also connect population data. I need to also connect building data downloaded from OSM. And that now you have source of databases. Now you need to design a good schema when you do analysis on top of it. What type of common schema you can come up with? That's where relational data relation tables comes in. You will have one table. How you gonna connect with another table? What is the primary key between two different tables? How you gonna connect with another third table that is coming into your architecture? So schema really important. Now after you determine I have this schema, this is the schema I'm gonna use. Managing indexes is really important. I have seen a lot of case and scenarios, people complaining, hey, I have like 5 gigabyte of table, it's really slow. I cannot even extract data out of it and it keeps growing and growing. But its problem is not 5 GB of table. Problem is how you manage 5 GB of table. Schema comes into the play. Processing of the data comes into the play. Choice of the database comes into the play. Where you are putting your 5 GB of table. How you are managing it. If let's say, as I was giving example of cadastre, I will again give example of cadastre. You have cadastre for all over your country. You have geometry for it. But if you do not have indexes on geometry, what are indexes? Indexes is just how you remember, right? Let's say you met 1,000 people in a conference, and then you are remembering them by their hair, or like, okay, they all wore black t-shirt, white t-shirt. You have some way to remember them, and you know, okay, they are there. If I need to find people from fast, I need to go to this conference because I know they will be there. So if you have some way to remember something, where to find them, that is index. And database has very cool way to manage indexes. I won't go through the very deep detail. It can get as complex as it is, but in summary, how you manage your indexes. If you are looking, okay, I want cadastre in this area and in this polygon, in this district. If you are looking based on your polygon, you need to build indexes on your spatial fields, right? You need to build your indexes on geometry so that your database will remember where each feature is. But if you are querying it based on district, maybe you need to build your indexes on district ID, right? So managing indexes is a crucial part when managing large spatial data. So like, as I said, one couple of minutes ago, it's not a problem how big your data is. The problem is how you are handling, like how you come up with the solution. I won't say like 5 giga, 10 giga is problem. Like even it's a terabyte of data, we can manage it with the help of indexes, right choice of database, right choice of schema that you have, how you process the data, right? Now there comes the query plan. Okay, you are done with, I know I am only going to retrieve my data based on district. Then I will build indexes on district so that my database will remember which rows are in that district. All the cadastre is in this district. So when you come, hey, give me the row of my Parbat district, then it will remember those are the rows in the Parbat. I will give it to him. So when you build indexes, this is how it will work. It's not as simple as it, but basic concept, you will get it. Now, you build the indexes, you have a good schema, you went for good database, let's say Postgres. You know how to process your data. You know it will always come in save file. You process it, process your save file, put it into as a row in your Postgres or table. Now you know how to process it, how to put it in the schema you designed. You already understood your data. Now, the another part is how you extract your data out of your database. That is also very important. Let's say you have indexes in district, but you are trying to extract it on the basis of VDC, village. We don't have village anymore. Basis of local municipalities. It won't work, right? It might work, but it will be super slow. How you fetch your data is also very important. How you, since you have it, even though you have indexes, but how you fetch, are you really using those indexes? Are you constructing your queries on the basis of the indexes you have, on the basis of the data you have in your database? This is very important. In terms of application, where it comes, like when API is fetching the data from database, you cannot construct like, okay, simple, get all the features that has x is equal to y, until and unless you are make sure when you shoot x is equal to y, what is the condition it's gonna hit, which indexes it's gonna hit, which table it's gonna scan, how many rows your query gonna scan in order to retrieve that row, right? So you need to make sure you are extracting the data out of database in a good, like at least like a efficient manner. That is where query plan comes in. And there is also a feature of like scalability. So how you scale your database when there is, okay, it is 5 years old, it is 2 years old, scalability also plays a role. I spent too much time explaining that, so I will be quicker through my next slides. Experiments. So what are the experiments that I have been doing? Now it comes more like my personal thoughts and experiments. So I was experimenting with OpenStreetMap data. So OpenStreetMap data, I was dealing with whole planet OpenStreetMap data because we would store in our professional work where I work, whole planet data of OpenStreetMap. And then at that point, like I went through the same, like this is something I just wrote on top of my head that I followed before. I might be missing some steps, but yeah, like more or less I went through the same thing. Did I understand the data? How data coming from OpenStreetMap? How people use it? How often does it update? It updates every minute. How often? How many rows it's gonna update? 1,000, 10,000, 50,000, right? How much volume that I am dealing with? And then I just like I divided my research in those components. So if you see here, like on the left side of the screen, this is the schema I come up with for the OpenStreetMap data in order to manage it very efficiently. Previously, like let's say OpenStreetMap is very flexible. Like if you enter tag as a tech and value as a Kshetri, it will have a whole new column in geospatial world, right? It won't matter in non-spatial world, but it will matter in spatial world because when we are dealing with table, it will have tech column and Kshetri in a as a value in a row that you inserted, but rest of the row for whole over the planet, it will be null. It was like that before. And then that's why like okay I decided no, this is not a good way. I will structure it was a good way before, but when we are dealing with the spatial data and also like we don't want to have database like as big in 5 terabytes 6 terabyte, right? So yeah, I put everything into JSON-B so that they won't consume each column for the each key, and then we won't have too many keys. So yeah, this is the schema. I won't go through everything, but this is the schema I come up with. And then I analyzed, okay, what type of how much volume we are talking about. Nodes is 473 gigabyte. OS is like 327 gigabyte. Relations are 5 gigabyte. More or less, like we are dealing with 1 terabyte of data. Like when you process it, it will also become 1.5 or 2 terabyte. And then I divided it. Okay, how I can divide it? How I can make maybe small tables based on how I can classify them. If there are polygons, I will put it in a single table called polygon. So if people coming looking for building, I won't have to look up the whole table, right? I will only look up into the polygons. I did the same for line. I did the same for point, and I got rid of the. I only store the points that has tags because, like, let's say, in order to construct a polygon, there will be four points. If I'm storing all those 4 points in my database would be super huge. So I got rid of them. But yeah, you can read the contents on there. I won't go through the detail, but one major thing to follow here is I followed the same approach. I try to understand that data. I come up with the schema that could be best fit for us. I divided the data into multiple small chunks so that whenever we process it, it will go into the same way that we designed processing of the data. I analyzed it, and there comes the query plan also, which I will be sharing on the next slide. So where DuckDB comes into the play now. Postgres is great. I already told like Postgres is great. I think I even maybe laughed up much about Postgres, but Postgres also has like a Postgres won't be useful every time. Let's say Google released Google Buildings version 3, which is worth of I don't know 10 gigabyte, 15 gigabyte, but it is pretty like pretty heavy. Now you just need to extract it for your area, for Pokhara, for your Kathmandu. But here you are dealing with 10 gigabyte of data. Google won't give the data set of Kathmandu for you. It just released the data set globally. Now you need to process it, and you need to only get the data out of data that you need. Maybe Kathmandu, maybe just filter it. Or like you are only looking for trees, and you got whole points for your for the country, right? Same goes for like recently, if you have heard of Overture is another open source data provider is the claim. They also released open data sets, but it's in Parquet, it's in gigabyte of data. Now you need to process it. You need to make sure you only get the small portion or some portion that you are looking for. Now you don't want to install like whole Postgres, do all the cleaning, do all the processing, put it in a Postgres, design something, maybe set up Postgres REST in order to get data out of the Postgres, and again convert it into save file, GeoJSON, GeoPackage, and put it on your GIS. Very long process, right? You just need something that is very quick. Okay, I will do this, but if we still want to suit the query, you don't want to lose having luxury of shooting queries, right? Shooting queries is really great. You can do crazy things about queries. Like um, you can build very complex queries saying x is equal to y and x is not false in z and z is part of this, part of this. You can build like huge complex queries. You want to have that flexibility. That's where DuckDB comes in. DuckDB is very powerful. Like whenever you query based on column of your data, it becomes extremely fast as compared to Postgres or any other uh, databases. That I noticed when I was using DuckDB. I was not using indexes. Even not using indexes, DuckDB was fast enough to get the features out of the database. Postgres will work fine, work great when you have indexes, when you build indexes, when you know where to build your index, when you know where you are looking. But if you do not know, you are fully on blank, you just want to get data out of it and do some like analysis on your laptop. You have good laptop, everybody has nowadays, I guess, 8 cores, 6 cores. But you really want to use it, DuckDB is the way. It has also support for a spatial, non-spatial query. As I said, uh, it can be very useful for Google buildings over your datasets and your custom datasets. So DuckDB is great. As I said, Postgres is also great, but it really depends upon the use cases. If you wanna, I gave example of you can extract over your data sets, you can extract really big Google buildings, Microsoft buildings for your area. You can use DuckDB for that. You don't need to set up anything, just download it, insert it in DuckDB, do some query, do st intersects in your geospatial, and it will give you your area that you're looking for, right? Here comes Postgres and DuckDB. I also wanted to quickly touch upon this. Those both can work. Very interesting. They are not rivals, right? They both can work great together. So the way I experimented it is like, so we were doing country experts. When we are doing country experts are really big. Like let's say when we are doing Nepal expert might not be that big. It's still a big, like 5 giga, 6 giga. But like let's say when you are doing expert of India, China, Russia, right? Now, like there comes Postgres. Let's say we have indexes on Postgres. Postgres was indexes, let's say with geometry indexes. It's a gist index. And then the way we work, we cluster them, we put them in a single, like physically cluster the rows into the database. That might not make sense, but leave it. But just we cluster them, to make efficient data. Now, let's say if I want to extract whole Nepal, but I want to extract health facilities, educational facilities, all of them is a different files, right? It's not a single query. It could be 15 query, 20 query, 25 queries. And also not only on top of it, you might need different file formats. Somebody needs 𝗘𝗀𝗃. People like me might hate save file. I need GeoPackage, or somebody needs other software. There comes like multiplies by 2 or 3, like you will have 100 queries, 150 queries. So there comes DuckDB. What I did, experimented here. DuckDB has support for Postgres. It can query the data from Postgres, place it in a DuckDB. So when I extract, let's say when we get extract request for Nepal, we calculate the BB box. We get all the features in that area from Postgres. All the features. We simply put it in a DuckDB so that we'll leave Postgres from here. And rest of the points, I want to extract education features. Since it's a column data, right? Education is where education facility is equal to school, where amenity is equal to this. Now DuckDB excels at this stage. It does not need indexes in order to extract, like let's say, a couple of gigabytes of data. It works great. And then we simply shoot all the queries into DuckDB and then extract the file. In this way, we avoid network call. We don't need to bug Postgres for everything. We don't need to build all the tags index on the Postgres, right? And also performance is pretty decent. I'll also share the performance metrics later on. So walkthrough. This is the query plan I was talking about before, right? So it is very important how you extract the data. So this is one example how you can actually, okay, on this query, for this exercise, what I did is, so look into this, and I just want to show you how powerful Postgres or database can be when it comes to large data. So I quickly downloaded whole data that is exist in OpenStreetMap in India. right? It was around I don't know, 2 GB or something, and it resulted in my database around 9 GB, right? Even though it has 90 GB, I quickly look at my index. I quickly build index on the geometry, and I wanted to find all the buildings in New Delhi, right? So look into this as a special query, all the buildings, New Delhi. I will shoot it right away. Let's say I'll shoot it right away. I have all the buildings in New Delhi, 2,004, 2,40,000 something, right? Or if I don't count it, I need all the geometries. There I have it in the New Delhi. So OSM ID is like I am getting that I am getting the New Delhi boundary here so that it will be easy for me. Let me show you the New Delhi boundary as well. So let's say run this query and then show you the geometry. This is New Delhi, right? Let it come. Yeah, this is the New Delhi boundary. And then I'm just like in my table, which is 4 GB of table, I am getting all the buildings in the New Delhi in just less than a blink, in milliseconds. This is how powerful Postgres can be if you know like how to use it. But if I didn't build an index on it, it might take an hour, 50 minutes, 30 minutes. And then that's where like indexes come into the play. How you, okay, make sure you are using your indexes when you are making your query, right? You explain and you will go through the query plan. Database has cool way to give the query plan. So if you see this in relation, I don't have indexes on OSM ID. That's why it is scanned whole devil. But since it's a primary key, it has sequential, it has some indexes on the ID. And here is my index. So that's where it only scanned, see, like 80,000 rows because it know where to look. Otherwise, it would have scanned whole 4 GB of table, right? And I got my query back in 512 milliseconds. This is how fast database can be. And this is how you can manage, even though you have big data, right? And yeah, for this exercise, I only loaded India. I could have loaded Asia, but I don't have enough spec on my laptop. So I didn't went for Asia, but I will show you how it will work for a whole planet, right? So we have loaded whole planet, and then I think it's around 1.6 or 8 terabyte of data. And then let's say, and I will show you like how fast it can be when we, so like in our database, we have 1.4 terabyte worth of data for whole over the world in OSM, updating every minute. It's not like it's not static also. And but if I want to, a normal guy comes into Pokhara and only says, I want features, buildings, specific buildings, don't give me anything else. And he might say, I want like weird other query. I want education facilities that has that is not primary schools, or I want only educational facilities which is primary, something like that. And you export it. It will go to the database. It will make a query and it will make sure that it comes back. It came back, right? It just, I don't think it took less than a second in order to extract data that you want in your area from 1.4 terabyte of database, which is updating every minute. So this is how it can be handled. And I'm not sure it is perfect. Like there are a lot of deficiencies still, but it's still one way to go. Second thing, I talked too much about DuckDB. So what I did is I created this resource called Overture Data DuckDB. I will share the GitHub link before. It's not perfect. I just started today, but it has enough resources for you to go through. If you click on Overture DuckDB, I have explained what I did. I will explain quickly here what I did. I downloaded from Overture all the administrative boundary all over the world, right? And I uploaded Nepal administrative boundary. And then I only want to have Nepal administrative boundary from all over the world that I just downloaded. I downloaded it in Parquet format. It is very popular, but it's another discussion. Parquet is very cool. Another geospatial format, cloud native format. It has compression. But yeah, like they provide data in Parquet also. So I downloaded them. So look into this. I downloaded the Nepal GeoJSON from OSM. So I downloaded, this is OSM ID for Nepal. And here, I don't have Postgres installed here, right? It is just a simple Python script. Here, I imported DuckDB. I have database now. I can create database in a disk. And good part of it, I created a table called ADB, administrative boundary. From the data I just downloaded, I'm not even looking at the data. It could be around 1 giga or 1 point, I think it was around 2 gigabyte of data. And then I installed a special extension, which is a geospatial extension in DuckDB. And now I said, okay, create my Nepal table first, and now I will do the query. So I want to see the first data, what it contains. Oh, it has geometry, it has baby box, it has sources, right? So this is my data I got from my downloaded huge open administrative boundary of whole world. Now, it's not that huge, like it's not called huge, but it's around 2 gigabyte. Here, I run this query. Look at this query. It's a spatial query. I'm not even using PostGIS. I'm not even using a huge database engine that I need to set up, server and everything, keep it running, nothing. I just imported a library, import DuckDB. I created a table. And if you look into this, I am saying that give me all the administrative boundaries where your geometry in the table that we downloaded intersects with my geometry that I just provided. Give me all those. And I shoot the query. It took a couple of seconds and it gave me 170 rows from whole whole administrative boundary, right? It gave me 170 rows in a couple of seconds. And then what I did, power of DuckDB, I exported that 170 row into GeoJSON and I loaded them in my QGIS, right? Now, in this easy way, I just processed gigabyte of data using DuckDB without installing anything fancy. Just couple of I created this database on my disk that might vanish couple of days after, and then I extracted the data I need. Right. Same goes for building. Same goes for other things or like any other analysis that you want to do. So this is also power of DuckDB. And yeah, you can run this script on your own. It's a notebook. I also provided a couple of resources. There is also one section here called why I use Postgres and DuckDB both together. What I faced. So for me, so initially I was using Postgres for everything, for shooting all those, as I said, 50 queries. And it took me more than 12 hours to extract India with all the categories. And when I started using DuckDB, transfer everything from Postgres to DuckDB and then shoot. Since DuckDB supports parallel execution, it supports multi-thread, right? It took me 4 hours to extract everything in India. I think it was around 20 gigabyte of file that it produced. So yeah, this is type of the performance, but yeah, it might not be good comparison because Postgres also has indexes. Yeah, there is a lot of work need to do. It's still, it could be a baseline. It could be something you can start with. I also provided a reference, which is, if you go here, there's a cool article that I love by Chris Holmes. Is he did performance exploration of GeoParquet and also the DuckDB. So yeah, you can see like there is a Parquet, there is Geo package, there is FCB and save file, save file, and also like yeah, you can see how file size difference, how DuckDB also difference, how DuckDB performs, and also a couple of stuff here. And also I provided relevant code that how you can pull your data from Postgres to DuckDB. I provided example of code here, and you can go through this GitHub, and which I will populate later on and keep working on it. And you are welcome to raise PR, by the way. And what next? That's all. This is half of me. This is full me. Feel free to contact me. And then I will pass it back to tech. Let's head towards the questions. I know this session is not that interactive, but which I do not hope. So I just wanted to provide the information. Okay, back to tech. Thank you. I cannot hear you.
Oh, sorry, I was muted.
Okay.
Can you hear me? Okay. Yeah,
Yes.
it was like great presentation. Thank you very much for like explaining all the chunks and all the tips and tricks, and also for the like last session, like you showed some of the like queries or hands-on tutorials. Please provide the tutorial links in the chat as well, or later we can share it via our Google group. So anyone who is like not joined in our Google group meet, please join it. You can find the I think information uh, on our Facebook page, or we'll simply edit in the chat as well. So yeah, that was great presentation. Thank you very much, and we are open for the question and answer session. So if you have question, feel free to write it in the chat, or feel free to unmute yourself and then directly ask to Kshitiz. And there is a question, but I think it's not related to DuckDB. Hello, I do upload this video on OSGeo Nepal YouTube channel. Yes, we'll upload it into our OSGeo Nepal channel. Yeah, the recording will be provided. Okay, yeah. So maybe I can start asking questions. So later on, okay, we have a question here. So I'm going to read it for you. So Pratiksha is writing, how interpretable was DuckDB when you tried to migrate your content from PostgreSQL?
Yeah, it's a good question. It's a great question, actually. I did tackle so many problems. For example, let's say initially DuckDB didn't use to support multi-polygons, multi-line strings. And then, like, as we both know, like, multi-polygons contains weird geometry, like some polygons, holes in between, especially when it comes to roots. And it didn't support at all. Currently, that's the first problem I tackled with. So I had to cast my geometry into a like universal geometry column so that it can contain everything instead of having specifying it as a multi-polygon. That's the one thing. Second thing is about like DuckDB. Sometimes it crashes because it tries to hyper thread everything. It tries to process everything in the threads and then get it done very quickly, but it could be resource hungry. Like it can eat up all your RAM, eat up all the cores you have. So you need to really be cautious that, okay, this is the amount of thread I need to supply to DuckDB. And that's also one of the problem I tackled when I transferred some of the content from Postgres to DuckDB. So those two main things. And for me, major thing was the geometry type. But nowadays, like I think if you use DuckDB right now, they support multi-polygon and multi-line strings. So that part is solved, I guess. But it's still the threading is used there. But it's still like I'm not completely migrated from Postgres to DuckDB, right? I only use DuckDB if I have to do really intense computation. Like let's say if I had to really extract the whole country and then divide it into 15 categories and suit all the queries in DuckDB instead of Postgres, so that I won't need those indexes in Postgres. So it's not a complete migration, it's partial migration.
Mhm.
Thank you for the question.
Okay. So I have another question. I have lots of questions, so I'm going to ask anyway, but
Yes.
I want to start from here. Uh, how big is the DogDB like developer community? Since it's new, does we get any kind of support on internet, like on Stack Overflow or even the GitHub Copilot, or in the like Chat GPT? How is their like community, or how is support?
Yeah, that's good. Nowadays, LLMs are becoming very popular. People tends to use LLM when they get a stock. I don't think you will get answers from LLM because like DuckDB is pretty new and like people barely talk about. If people now start getting problems, so it might not be also. when I was debugging back then, since DuckDB is in production, I need to make sure that people, like, whenever people suit, my system does not die. And my only source was GitHub issues and the people who were commenting on it. So developer community is pretty limited, but I think this is something won't happen in near future, but it gets like whenever it gets start popular getting a start popular, and then people start coming in and we'll have a developed community. But nowadays it's pretty limited.
Yeah. Thank you. So if other have no questions, so I have another question as well. Uh, so we mostly talk here about the vector data set. What about the raster? What about raster in PostgreSQL or DuckDB? So I have tried once raster in PostgreSQL, but I have no idea. Like I have no idea how to query it or how to visualize it or what is the use case of raster. So can you explain that a little bit?
Yes, this is also, thanks for touching upon this point, because this is also one thing I missed that is present on my slide, but I missed explaining. So DuckDB currently fully focused on vector data sets, but I won't be surprised if developer comes with a raster support or any other people volunteer for it. But based on my experience with PostgreSQL, like with PG raster, busy routing, tried to cover some of the raster data set, but initially Postgres was not designed to support raster. It was mainly for like columnar data, and that's where vector data jumped in. PostgreSQL supported vector most of it, but still there is a like. I also feel there is a lack of support for raster both in Postgres and DuckDB. So DuckDB, like, no, but Postgres there is a raster support, but it's still like it's pretty limited.
Okay, yeah, thanks. So yeah, basically when I try to like compare PostgreSQL with DuckDB, I have like never have any hands-on experience on DuckDB, but it still feel like it's like the database in our own hand. So we don't need any kind of installation or the we need installation, but it's just like running one line of code,
Yep.
and then it is, I think, lightweight as well in compared to PostgreSQL. Which give lots of flexibility. Definitely, I'm going to try it in near my future. Whenever I need, mostly for the big data analysis. Yeah, that's great. So, are there any questions? Okay, just wondering. So, I feel like since it's new, there might not be an ORM available, object relational mapping. So, for the people who doesn't know about ORM, it's like writing your query in term of function or in term of object. For example, if you write country.object.all, then you should get all the countries in a globe. So it's like it's ORM is a like a minified version of your query. So does the DuckDB has ORM feature available? ORM, like any extension or any support on that?
Yes. So DuckDB DuckDB provides DuckDB API that you
Mhm.
can incorporate with Python, R, or any other client. That's how DuckDB Python was developed. It's not using the core DuckDB CLI, but it can use the DuckDB Python. Why I am saying this? Because it gives the flexibility for other developers to build ORM on top of it. And there is already a commercial software providers like MotherDoc also provides ORM for DuckDB, but it's not open source, but they provide ORM for DuckDB. And I think there are a couple of open source projects that is just starting, but I haven't used them yet. So I mostly play with the raw SQL query, but I do know that since API is available, it's just a matter of time when developers comes with the solid ORM, because they can simply utilize the API and build a ORM on top of it.
Yeah, yeah,
So yeah, I see the possibility.
yeah, maybe it's not that perfectly mature. That's why people are still
Yeah,
not building the ORM. But yeah, definitely in future, it might have some like some build up. And I see the
That is
another
a
question. Yeah.
ORM for Mother Dog. So Mother Dog is
Okay.
also commercial provider, and they provide ORM. So yeah, it's pretty. Let's hope
Yeah.
it would be there.
Okay, I see another question in chat by Ravina. So she's saying that is there any possible way to integrate DogDB with GeoServer? Is there any relation?
Hmm. I'm not that used to GeoServer. I haven't looked into the GeoServer code yet, how GeoServer works. I mean, like, I know how GeoServer works, but not in the code level. So I haven't really, I cannot really answer this question. So the way I see it, DuckDB is like mainly people are using it for analysis purpose. Like you can use the Python API, you can use other API, load your data, but get the useful data out of it. But as mentioned in the previous, it does not have efficient ORM like services like WFS, WMS, or even a vector tiles. There is a support for MB tiles or something. But yeah, vector tiles is also something people are experimenting with. So I do see there could be integration with GeoServer, but yeah, I don't know exact answers that it could be possible. It might not be. I need to look into the GeoServer code. Yeah,
Yeah.
sorry
Okay.
about that.
Yeah. Yeah, it's okay, and no worries. So yeah, maybe I also feel the same. So basically, I feel like the DogDB is like mostly useful for the analysis, querying, and then getting the perfect result, or even like clipping buffering might be possible.
Yeah,
But if we like take the GeoServer is mostly deal with the like visualization and then exchanging the vector or raster file format. So I feel like there maybe yeah, people have already integrated, but I am not familiar with it neither. Yeah. Okay, any other questions? You can unmute yourself and ask if you like.
or you can choose like ask in Nepali.
Yeah.
That's okay as well if you are comfortable enough.
Okay, I think okay. Pritam Gurung. Yeah, go ahead. Oh, he's mute. Sorry. Okay, then that's all about today's session. Thank you very much, Kshitiz, for sharing your ideas, presentation, and all the like workflow and resources. So we really enjoy your presentation, and we'll continue this Geo series technical session maybe on 14 days or in a month interval. If you want to get in touch with us, please connect in social media or Discord channel. So thank you all for joining today's session. So we are closing it here now. Yeah.
Yeah, thank you all.
Thanks.
Recording
Before
has
closing,
stopped.
this is also jointly organized with NGES, so you can feel free to contact NGES or OSGeo Nepal related
Yeah.
to the GeoServer.